Now, in this lecture, we'll answer on two questions. In the first question, we'll find out the blue area, and in the second question, we'll find out the radius of this circle that blocks triangle ABC. So we start with the first question. In the drawing, we have a circle, and we know that AB is the diameter of this circle, and the big circle blocks triangle ABC. Triangle ABC is inscribed by the big circle, and the small circle is inscribed by triangle ABC, and we want to find out the blue area. So first of all, we will define the center of the small circle as point O. Actually, we also know that the radius of the small circle is equal to 4 units, so we define the radius of the small circle as small r, and the radius of the big circle equals to 13 units. We define the radius of the big circle as capital R. Okay. We define the point of tendency B with this small circle as point A. Actually, we define the point of tendency B with this small circle as point L. We define the point of tendency of tangent AC with this small circle as point M. We join points O and L together by a straight line. Actually, point O is the center of the small circle, and point L is the point of the small circle itself. This is exactly the definition of a radius. That is to say, LO is the radius of the small circle, that is equal to small r, that is equal to 4 units according to what's given as the question. We join points O and M together by a straight line. Here again, O is the center of the small circle, M is the point of the small circle itself. That is to say, OM is the radius of the small circle, that is equal to 4 units. And we have rule number 1, that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AC with this small circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius MO. So if AC is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have here the radius OL, it is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent BC with this small circle. Whenever we have a radius that is drawn to the point of tendency, then the tangent BC will be perpendicular to the radius LO. So BC is perpendicular to LO. It means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And we also have the rule that any peripheral angle that rests on the diameter, we know that AB is the diameter of the big circle, and we have the rule that any peripheral angle that rests on the diameter of a circle is equal to 180 degrees. So here, peripheral angle ACB, this angle ACB rests on the diameter of the circle that is AB. Therefore, according to the rule that I mentioned, peripheral angle ACB must be equal to 90 degrees. So here actually in quadrilateral OMCL we have 1, 2, 3 right angles. So write it down. In quadrilateral OMCL we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle LOM, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that the missing angle NOM is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. Okay, so from that, so the missing angle here, angle NOM equals to 90 degrees. It is a right angle. So actually, in quadrilateral MOCL, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral OMCL as a rectangle. Okay, quadrilateral OMCL is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle OMCL, they are equal to each other. It means that OL equals to MC. Here, OL equals to MC. If OL equals to MC, OL equals to MC. But here, according to what we have already found out, OL equals to 4 units. It is the radius of the circle. So from this equation, 4 equals to OL equals to MC, we derive that MC is also equals to 4 units. MC equals to 4 units. Here we can write down that MC equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MO equals to CL. MO equals to CL. But MO equals to 4 units. It is the radius of the circle. MO equals to 4 units. And from this equation, 4 equals to MO equals to CL, we derive that CL is also equals to 4 units. CL equals to 4 units. So here we can write down that CL equals to 4 units. So actually we found out that the quadrilateral MOCL is not a rectangle but a square. Okay. So in the next step I present to you rule number 2 that I have already mentioned in the past. According to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. The lengths of 2 tangents from a common external point to a circle are equal. It means that if you have 2 tangents to a circle from a common external point of that circle, then the length of those 2 tangents must be equal to each other. So here we'll focus on the common external point, point A. In this point A, the common external point, point A, we have 2 tangents to this circle. The first tangent is tangent AM, and the second tangent, here we'll define the point of tendency of tangent AB with this small circle SS. So from the common standpoint, point A, we have two tangents to this circle, tangent AM and tangent AS. And according to rule number 2, the lengths of those two tangents must be equal to each other. So here AM must be equal to AS according to rule number 2. But before that, we have what is the length of line segment AM. The length of line segment AM, from the drawing it is very easy to see that the length of line segment AM is AC minus MC. AC minus MC. So we define AC as A and MC equals to 4. So in conclusion, we found out that AM equals to A minus 4. A minus 4 because of the fact that here AC equals to A according to our definition. AC equals to A. Therefore, AM equals to A minus 4. And we'll define CB as B. Here, CB is equal to B according to our definition. So what will be the length of LB? From the drawing it is very easy to see that LB equals to CB minus CL. CB minus CL. So LB equals to CB, that is B, minus CL, that is 4 units. So in conclusion, we found out that LB equals to 4 minus B minus 4. B minus 4 units. So we'll continue with rule number 2. According to rule number 2, if we focus at point A, then at point A, from the common standpoint point A, we have two tangents to this circle, tangent AM and tangent AS. And according to rule number 2, AM equals to AS. Okay? But we already found out that AM equals to A minus 4. So we can write here that AM equals to A minus 4. And from this equation, A minus 4 equals to AM equals to AS, we derive that AS is also equals to A minus 4. AS equals to A minus 4. So we can write down here that AS equals to A minus 4. In the next step, we will focus on the common external point, point B. Here, from the common external point, point B, we have two tangents to this circle. We have tangent BS, and we also have tangent BL. And according to rule number 2, those two tangents are equal to each other in their length. That is to say, BS equals to BL according to rule number 2. But BL equals to B minus 4. According to what we have already found out, BL equals to B minus 4. So if you write here that B equals to B minus 4, and from this equation, Bs equals to Bl equals to B minus 4, we will derive that Bs is also equals to B minus 4. Bs equals to B minus 4. Okay? We can write down here that Bs equals to B minus 4. According to our definition, here AB equals to C, but according to what is given as the question, AB is the diameter. The diameter is always twice as long as the radius, so if the radius of this the big circle is equal to capital R, the diameter will be equal twice as long as the radius, so it will be equal to 2 times capital R. But it is given as a question that the radius of the big circle equals to 13 units. That is to say, 2 times the radius of the big circle, that is 13 units, it is 26 units. So here AB equals to 26 units. So actually, you can create here equation number 1, that is the length of the diameter AB. So the length of the diameter AB, that is equal to 26 units. It is equal to A minus B, A minus 4 of course. AS is A minus 4 plus SB, that is B minus 4. Repeat again, the diameter AB of this circle that is equal to 26 units is equal to A minus 4 plus B minus 4. So that is to say here, according to equation number 1, we will get that 26 equals to, here it is A plus B, minus 4 is minus 8. So 26 equals to A plus B minus 8. Here we will add 8 to this equation, equation number 1, and we will get that according to equation number 1, A plus B equals to 26 plus 8, that is 34 units. So here we'll square this equation, equation number 1, and we'll get that A plus B squared equals to 34 squared, that is 1156. Okay? So here we'll open the brackets on this side of equation number 1, and we'll get that A plus B squared equals to A squared plus B squared plus 2 times AB, and it is equal to 1156. Okay? But we have already found out that triangle ABC is a right triangle because of the fact that angle ACB equals to 90 degrees. So we can implement the Pythagoras theorem on the right big triangle, triangle ABC. We'll do it now, and we'll get that according to the Pythagoras theorem on the right big triangle, triangle ABC, by PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. the hypotenuse is AB, that is equal to C. So the square of the hypotenuse is C squared. And it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to AC squared, that is A squared, according to our definition, plus BC squared, that is B squared, according to our definition. So in conclusion, according to equation number 2, and Pythagoras theorem, we got that C squared equals to A squared plus B squared. But we already found out that C equals to 26 units. The diameter of this circle equals to 26 units. So C squared is 26 squared. 26 squared is 676. That is equal to A squared plus B squared. Because of the fact that, according to equation number 2, A squared plus B squared equals to 676, here we substitute A squared plus B squared in equation number 1 here by 676. Okay? We do it now, and we get that A squared plus B squared is 676 plus 2 times AB, and according to equation number 1, it is equal to 1156. Here we subtract from this equation number 1, 676, and we get that according to equation number 1, 2 times AB equals to 1156 minus 676 is 480. Here we divide this equation number 1 by 2, and we get that 2 times AB over 2 is AB. AB equals to 480 over 2 is 240. So we found out that AB equals to, according to equation number 1, AB equals to 240. And what is the area of the blue shape? The area, it is very easy to see that the area of the blue shape is equal to the area of the big triangle ABC minus the area of the small circle, this small circle. So I write it down. The area of the blue shape equals to the area of the big triangle ABC minus the area of the small circle. Okay? The area of the small circle. So the area of the blue shape is equal to the area of triangle ABC. The area of triangle ABC equals to the base of the triangle, that is AC. AC equals to A times the height to the base. The height must create 90 degrees with the base, so it is CB. But CB equals to B. So it is A times B over 2. A times B over 2. It is the area of the big triangle ABC. But according to what we have already found out, A times B equals to 220. So here we can divide this equation by 2, and we'll get that AB over 2 equals to 240 over 2 is 120. So AB over 2 equals to 120. So here we can write down that AB over 2 equals to the area of the blue shape. It is equal to AB over 2, it is 120 minus the area of the small circle. The area of the small circle equals to pi r square, r equals to 4 units, so it is 120 minus pi times 4 square. So it is 120 minus 4 square is 16, so it is 16 pi. So in conclusion, we found out that the area of the blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. I'll repeat again. The area of the blue shape, the area of this blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. So finish with the first question. In the next step, I will present to you the second question, and we will solve the second question in 3 different methods. Okay, so here in the drawing, this circle inside this circle blocks triangle ABC. Actually, triangle ABC is inscribed by this circle. We know that the area of triangle ABC equals to 9 square units. The length of side AB is 5 units. The length of side BC is 6 units, and we want to find out the radius of this circle that blocks triangle ABC. So in the first step, we will draw perpendicular from point A on BC. Here, this is BC. So from point A, we will draw perpendicular on BC. So this angle equals to 90 degrees according to our construction. This angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as E. Okay. So we define it as point D. We define the touching point of the perpendicular from point A and BC as D. We actually know that the area of triangle ABC equals to 9 square units. So we can write here that the area of triangle ABC is equal to 9 square units. But the area of any triangle, it is equal to the base of the triangle. In this case is BC times the height to the base. The height to the base must create 90 degrees with the base. So here AD creates 90 degrees with the base, therefore the height to the base is AD over 2. So the area of triangle ABC equals to BC times AD over 2. But we know it is given us the question that BC equals to 6 units. So we'll substitute BC by 6 and times AD over 2. So here we found out that the area of triangle ABC it is equal to 9 square units, and here 6 over 2 is 3, which is 3 times AD. Here we will divide this equation by 3, and we will get that AD equals to 3 units. AD equals to 3 units, so we can write here that AD equals to 3 units. In the next step, we'll focus on the right triangle ABD. On the right triangle ABD, according to the Pythagoras theorem, by PT is the relation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AB square, AB square must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AD square plus BD square. Repeat again, according to the Pythagoras theorem, AB square must be equal to AD square plus BD square. AB equals to 5, so AB square is 5 square, that is 25. And it is equal to AD square plus plus BD square. Plus BD square. So 25 equals to AD square. AD equals to 3, so AD square is 3 square. That is 9 plus BD square. So in conclusion, we found out that 25 equals to 9 plus BD square. Here we will subtract 9 from this equation and we will get that BD square equals to 25 minus 9 is 16. Here we take a root out of this equation and we get that BD equals to the square root of 16, that is 4. So we found out that BD equals to 4 units. BD equals to 4 units. You can write here that BD equals to 4 units. What is the value of line segment DC? The value of line segment DC, it is very easy to see from the drawing that DC equals to BC minus BD. BC minus BD. That is to say DC equals to BC, that is 6 units according to what is given as the question, minus BD, that is 4 units according to what we already just right now found out. So this equals to 6 minus 4, that is 2. So we found out that this equals to 2 units. In the next step, we will focus on the right triangle ADC. We will implement the Pythagoras theorem on the right triangle ADC. On the right triangle ADC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AD square plus DC square. I repeat again. On the right triangle ADC, according to the Pythagoras theorem, we get that AC square equals to AD square plus DC square. So AC square equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DC square. DC equals to 2 units, so DC square is 2 squared, that is 4. So in conclusion, we found out that AC square equals to 9 plus 4, that is to say AC square equals to 9 plus 4 is 13. Here we take a root out of this equation and we get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. So we can write down in the drawing that AC equals to the square root of 13 units. In the next step, we will define the center of the big circle as point O. We join points A and O together by a straight line. And then we will extend line segment AO until it touches the circle, and we will define the touching point of the extended line segment AD with the circle, and the circle is point E. So chord AE passes through the center of the circle. Any chord that passes through the center of the circle is defined as the diameter. So we can write down that AE is the diameter of the big circle. Okay? And in the next step, we'll join points B and E together by a straight line. It is very easy to see that angle ABE, this angle ABE, rests on the diameter of the circle. Angle ABE rests on the diameter of the circle, that is AE. And we have the rule that any peripheral angle that rests on the diameter of the circle is equal to 90 degrees. That is to say, according to the rule that I mentioned, peripheral angle ABE that rests on AE, that is the diameter of the big circle, must be equal to 90 degrees. So here, angle ABE is equal to 90 degrees because angle ABE is peripheral angle that rests on the diameter of this circle. Any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. Therefore, angle ABE equals to 90 degrees. Okay? And we actually have another rule that states that peripheral angles that rest on the same chord are equal to each other. So here we have chord AB. On chord AB we have two angles that rest on chord AB. Angle ACB rests on chord AB, and angle AEB also rests on chord AB. So according to the rule that I mentioned right now, we will get that angle AEB, this angle that rests on chord AB, must be equal to this angle that is actually angle ACB, that is also rests on the same chord called AB. Chord ACB. I'll repeat again. Those two peripheral angles, AEB and ACB, rest on the same chord called AB, therefore they are equal to each other, according to the rule that I mentioned. So if we define angle ACB as theta, then here angle ACB equals to theta, then from this equation theta equals to angle ACB equals to angle AEB, we will derive that angle AEB is also equals to theta. Okay, so we write down here that angle AEB equals to theta. Okay, but if angle AEB, if we focus on triangle ABE, in the right triangle ABE, angle AEB equals to theta. Angle ABE equals to 90 degrees. So this angle, the third angle, must be equal to 90 degrees minus theta in order to complete the sum of the angles in this triangle ABE to 180 degrees. And exactly for the same reason, in triangle ADC, this triangle ADC, this angle equals to theta, this angle equals to 90 degrees. So this angle must be equal to 90 degrees minus theta, for the same reason. In the next step, we will prove that the green right triangle, triangle ABE, is similar to the green right triangle, triangle ADC. We'll prove that those two green right triangles are similar to each other. Okay, so write it down. We prove the green triangle, the green right triangle, triangle ABE, this green right triangle is similar to the green right triangle, triangle ADC. So why those two green right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle ABE in triangle ABE is equal to angle ADC, this angle, and both angles are equal to 90 degrees, therefore they are equal to each other. Okay, so angle ABE equals to angle ADC equals to 90 degrees. In addition, we have those two angles, they are both equal to theta, therefore they are equal to each other. Okay, so angle AEB equals to angle ACD, this angle, and they are both equal to theta, therefore they are equal to each other. I'll repeat again. Angle AB equals to angle ACD equals to theta, and finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So I write it down. Angle EAB, this angle is equal to this angle, that is actually angle DAC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. Actually, we found out that all the angles in triangle ABE can go into all the angles in triangle ADC, therefore triangle ABE is similar to triangle ADC according to angle similarity rule. So I write it down. Triangle ABE is similar to triangle ADC according to angle similarity rule. and from the fact that the two green triangles are similar to each other, we conclude that the following equation is true. We conclude that AB over AD equals to AE over AC. I repeat again, from the fact that the two green triangles are similar to each other, we conclude that AB over AD equals to AE over AC. So here AB equals to 5 units, AD equals to 3 units, A equals to, it is the diameter of this big circle is equal to 2 times capital R, and AC equals to square root of 13 units. So in conclusion, we found out that 5 over 3 equals to 2R over square root of 13 units. Here we will multiply this equation by square root of 13 units, by square root of 13, and we get that 5 over 3 times square root of 13 equals to 2R. We'll divide this equation by 2, and we'll get that the radius of the circle, capital R, equals to 5 over 6 times square root of 13 units. Or in terms of numbers, it is a little bit greater than 3 units. Okay. So we actually finished with the first method. The radius of this circle equals to either 5 over 6 times square root of 14 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, we finished with the first method. In the next step, I will present to you how to find out the radius of this circle that blocks triangle ABC according to the second method. We'll use all the things that we already found out in the first method here. So here from point A we draw perpendicular on BC. When you find the touching point of the perpendicular from point A and the BC as D, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. This is point D. AD equals to 3 units according to the first method. DC equals to 2 units here according to the first method. We have already found out according to the first method, the first method, that BD equals to 4 units. Here we will extend the perpendicular AD by a straight line until it touches the circle. We define the touching point of the extended line segment AD and perpendicular AD and the circle is point E. Okay? So here we have rule number 1. According to rule number 1, If we have this circle, this is rule number 1. Here, if chord AB, this is chord AB, intersects with chord CD, this is chord CD, at point O. Point O is the intersection point of chord AB with chord CD. Then the following equation is true, that AO over OB, AO times AB, AO times OB equals to CO times OD. The intersection point must occur inside the circle, not outside the circle. Okay? AO times OB equals to CO times OD. We can implement rule number 1 in our drawing. Why? Because in our drawing we have chord AE that intersects with chord BC at point D. Point D is the intersection point of chord AE with chord BC. Therefore, we can implement rule number 1 in our drawing. According to rule number 1, we will get that in our drawing we have BD times DC equals to AD times DE. I'll repeat again. According to rule number 1, BD times DC equals to AD times DE. So here, BD equals to 4 units, DC equals to 2 units, AD equals to 3 units, and DE is the missing 9 segments. So we leave it as it is. So in conclusion, we found out that 4 times 8 equals to 3 times DE. 4 times 2 equals to 3 times DE. 4 times 2 is 8. 8 equals to 3 times DE. Here we'll divide this equation by 3 and we'll get that DE, the length of line segment DE, is 8 over 3 units. 8 thirds. DE equals to 8 over 3 units. In the next step, I will present to you, actually, I will present to you rule number 2, but before that, here, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, so if we focus on this side of the straight line AE at point D, the sum of the angles must be equal to 180 degrees. So this angle equals to 90 degrees plus this angle. In total, the sum of those two angles must be equal to 180 degrees. So this angle also must be equal to 90 degrees in order to complete the sum of the angles to 180 degrees. Okay. Likewise, if we focus on this side of the straight line AE at point D, then the sum of the angles must be equal to 180 degrees. So which angles we have at point D at this side? We have 90 degrees plus this angle. In total, the sum of those two angles must be equal to 180 degrees. So this angle must be also equal to 90 degrees in order to complete the sum of the angles at this side of the straight line D, at this side of the straight line AE at point D to 180 degrees. So this angle must be also equal to 90 degrees. And AE is a straight line because of the fact that AD is perpendicular AD is a perpendicular, must be a straight line, and then when we extended the straight line AD by straight line, the result must be a straight line. So the result that is AE also must be a straight line. Therefore, AE is a straight line. So we found out that all the angles around point D are right angles. So in the next step, I will present to you rule number 2. According to rule number 2, if we have this circle, and we have two chords that intersect with each other at 90 degrees. Here, chord AB, this is chord AB. This is rule number 2. Chord AB intersects with chord CD at 90 degrees. Okay, the intersection point, they create 90 degrees with each other. We define the intersection point as point O. If CO equals to A in its length, OD equals to B in its length, AO equals to C in its length, and OB equals to D in its length, then according to rule number 2, we get that 4 times the radius of the circle that contains the two chords squared equals to A squared plus B squared plus C squared plus D squared. Okay, I repeat again. If we have two chords, chord AB intersects with chord CD at 90 degrees, then according to rule number 2, we get that 4 times R square equals to A square plus B square plus C square plus D square. R is the radius that contains the two chords. We actually can implement rule number 2 in our drawing, because in our drawing we have chord AE that intersects with chord BC at 90 degrees. All the angles around point D, around the intersection point, are equal to 90 degrees. Therefore, we can implement rule number 2 in our drawing. So in our drawing, according to rule number 2, we get that 4 times R squared, that is the radius of this circle squared, equals to BD squared plus DC squared plus AD squared plus DE squared. Okay, according to rule number 2, BD squared plus DC squared plus AD squared plus DE squared equals to 4 times R squared. So 4 times R squared equals to BD squared. BD equals to 4 units, so BD squared is 4 squared, that is 16, plus DC squared. DC equals to 2 units, so DC squared is 2 squared, that is 4, plus AD squared. AD equals to 4 units, so AD squared is 3 squared, that is 9, plus DE squared. DE is 8 over 3, so DE squared is 8 over 3 squared, that is 64 over 9. So here we get that 16 plus 4 is 20, and 20 plus 9 is 29, plus 64 over 9. Here we'll multiply 29 by 9, and then we'll divide it by 9 in order to have a common factor with this expression. And we get that 29 times 9 is 261 plus 64 over 9. So 261 plus 64 is 325 over 9. So we found out that 4r squared equals to 325 over 9. Here we divide this equation by 4, and we get that r squared equals to 325 over 4 times 9 is 36. 325 is 25 times 13, so we substitute 325 by 25 times 13 over 36. Here we will take a root out of this equation, and we will get that r, the radius of this circle that we are looking for, it is equals to square root of 25 is 5, square root of 36 is 6, times square root of 13. So in conclusion, we found out that r, the radius of this circle, equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay? So we finish with the second method. In the next step, I will present to you how to find out the radius of this circle that blocks triangle ABC according to the third method. In the third method, we will define angle ABC as theta. Actually, we have a special formula to find out the area of any triangle. If we have triangle ABC, that could be any triangle. This is triangle ABC. The angle between side A and side AB and side AC is theta. The length of side AB is A units. The length of side AC is B units. Then, according to the new formula, the area of triangle ABC is equal to A times B times sinus theta over 2. We will use this formula. So the area of this triangle ABC is A times B times sinus theta over 2. We will use this formula in order to find out the area of our triangle that is equal to 9 units, but in this way we'll actually find out the value of sinus theta. So the area of this triangle ABC, we know that it is equal to 9 units. The area of triangle ABC, it is equal to 9 units. And according to this formula, the area of this triangle equals to A times B, that is 5 times 6, times sinus theta over 2. 5 times 6 is 30, and 30 over 2 is 15. So it's 15 times sinus theta. So in conclusion, we found out that 9 equals to 15 times sinus theta. Here we'll divide this equation by 3, and we'll get that 9 over 3 is 3, and 15 over 3 is 5 times sinus theta. Here we'll divide this equation by 5, and we'll get that sinus theta equals to 3 over 5. Sinus theta equals to 3 over 5. But we actually also have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. That is to say, cosine theta equals to the square root of 1 minus, if sinus theta equals to 3/5, then sinus square theta will be equal to 3/5 squared, that is 3 squared, that is 9, over 5 squared, that is 25. Okay? So here we'll multiply 1 by 25 and then we'll divide it by 25 in order to have a common factor with this expression, and we get that 25 minus 9 over 25 squared equals to cosine theta. That is to say 25 minus 9 is 16 over 25. So cosine theta equals to the square root of 16 is 4 and the square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. In the next step, we will implement the law of cosines in our triangle ABC. Okay. So what is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. We know the triangle between side AB and side AC is theta. The length of side AB is A units, the length of side AC is B units, and the length of side BC is C units. Then, according to the law of cosines, this is the law of cosines. We'll get that cosine theta equals to A square plus B square minus C square over 2 times A times B. So we'll implement the law of cosines in our triangle ABC. According to the law of cosines, we'll get that cosine theta equals to AB squared, that is 5 squared, 25, plus BC squared, that is 6 squared, is 36, minus AC squared, that is the missing line segment, over 2 times 5 times 6. We have already found out that cosine theta equals to 4/5, so we substitute cosine theta by 4/5. Here, cosine theta equals to 4/5. Okay, so if cosine theta equals to 4/5, and it is equal to 25 plus 36 is 61, minus AC squared over 5 times 6 is 30, and 30 times 2 is 60. Here we will multiply this equation by 5, and we'll get that 4/5 times 5 is 4, equals to 61 minus AC squared. And here we have actually 60 over 5 is 12. We multiply this equation by 12, and we get that 12 times 4 is 48. So 48 equals to 61 minus AC squared. So here we subtract 48 and 8ac squared to this equation, and we get that ac squared equals to 61 minus 48 is 13. We take out of this equation, and we get that ac equals to the square root of 13 units. So we found out that this side AC equals to square root of 13 units. In the next step, I will present to you a new formula for a circle that blocks triangle. The radius of the circle that blocks triangle, like in our drawing, it will be equal to the multiplication of the sides of the triangle that is blocked by the circle. In this case, it will be AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. In this case, it is triangle ABC. So the radius of the circle that is blocks triangle, it will be equal to the multiplication of the sides of the triangle over 4 times the area of the triangle that is blocked by the circle. So capital R will be equal to AB is 5, AC is square root of 13, BC is 6, over 4 times the area of triangle ABC is 9 according to what is given as the question. So here we will have 5 times square root of 13 times 6 over 4 times 9 is 36. Here we will divide both the numerator and the denominator by 6, and we will get that the radius of the circle that we are looking for, here 6 will get cancelled, and 36 over 6 is 6. So we found out that the radius that we are looking for, it is equal to 5 over 6 times square root of 13 units. Or in terms of numbers, it is a little bit greater than 3 units. Okay, we finished with the third method. Okay, in the next step I will summarize the lecture. We'll start with the first question. So here we have in the drawing this circle. Inside this circle we have triangle ABC. Surely triangle ABC is inscribed by the big circle, and inside the triangle ABC we have the small circle. And we know that AB is the diameter of the big circle. The radius of the small circle equals to 4 units. The radius of the big circle equals to 13 units. And we want to find out the blue area. Okay. So first of all, we define the center of the small circle as point O. Here we define the point of tendency of tangent AC with the small circle as M. We define the point of tendency of tangent BC with the small circle as L. Then we join points O and M together by a straight line. O is the center of the small circle. M is the point of the small circle itself. This is exactly the definition of a radius. That is to say, OM is the radius of the small circle. We define the radius of the small circle as small r, and we know that small r equals to 4 units according to what is given as the question. So here we have the radius OM that is drawn to the point of tendency, and whenever you have a radius that is drawn to the point of tendency, then the tangent AC will be perpendicular to the radius OM. So AC is perpendicular to MO, that is to say this angle equals 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. Then we join points O and L together by a straight line. O is the center of the circle and L is the point of the circle itself. This is exactly the definition of a radius. So OL is the radius of this circle and the radius of the small circle. It is not the point L, it is the point of tendency of tangent BC with this small circle. Whenever you have a radius that is drawn to the point of tendency, then the tangent BC will be perpendicular to the radius LO. So BC is perpendicular to LO. That is to say, this angle equals to 90 degrees and this angle will also equal to 90 degrees. Okay? We know that AB is the diameter of the big circle. And we have angle ACB rests on the diameter AB. So the peripheral angle ACB rests on the diameter, and we have the rule that any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. That is to say, angle ACB, this angle equals to 90 degrees according to the rule that I mentioned. Okay? So we actually found out that in quadrilateral OMCL we have 1, 2, 3 right angles. I'll repeat again, in quadrilateral OMCL we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle LOM. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. If we subtracted 270 degrees from this equation, we found out that the missing angle LOM equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this angle is a right angle, it is equal to 90 degrees. Actually, we found out that in quadrilateral MOCL we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle. So we relate to quadrilateral MOCL as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle OMCL, OL must be equal to MC. Again, OL must be equal to MC. OL must be equal to MC, but we already found out that OL equals to 4 units. This is the radius of the small circle, so OL equals to 4. And from this equation, 4 equals to OL equals to MC. We will derive that MC is also equals to 4 units. Here, MC is also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MO equals to CL. MO equals to CL, but we already found out that MO equals to 4 units. This is the radius of the circle. So we can write here that MO equals to 4 units, and from this equation 4 equals to MO equals to CL, we will derive that CL is also equals to 4 units. Here, CL is also equals to 4 units. Okay, then we actually defined side AC as A, and we define side CB as B and side AB as C. Okay? And what is the length of AM? AM from the drawing is very easy to see that AM equals to AC minus MC. AM equals to AC minus MC. That is to say, AM equals to AC that is A minus MC that is 4. So in conclusion, we found out that AM equals to A minus 4. Likewise, it is very easy to see from the drawing that LB equals to CB minus CL. Again, CB minus CL equals to LB. LB equals to CB minus CL, so LB equals to CB that is equals to B according to the definition, minus CL that is 4. So in conclusion, we found out that LB equals to B minus 4. Here, LB equals to B minus 4. So we found out that LB equals to B minus 4 and AM equals to A minus 4. Then I presented to you rule number 2. According to rule number 2, the length of 2 tangents from a common extreme point to a circle are equal. Again, the lengths of 2 tangents from a common extreme point to a circle are equal. Then we focus on the common extreme point, point A. From the common extreme point, point A, we have 2 tangents to this circle. Tangent AS and tangent AM, and according to rule number 2, they must be equal to each other. So here AM equals to AS according to rule number 2, but here AM equals to A minus 4. We already found out that AM equals to A minus 4. So you can write here that AM equals to A minus 4, so A minus 4 equals to MA equals to AS. And from this equation, we can derive that AS also equals to A minus 4. Here, AS is also equals to A minus 4. Then if we focus to the common extent point B, from the common extent point B, we have two tangents to the circle. Tangent BS and tangent BL. According to rule number 2, they are equal to each other in their lengths. Okay? So here, BS equals to BL according to rule number 2. So BS equals to BL, but we already found out that BL equals to here. That BL equals to B minus 4. So we can write here that BL equals to B minus 4, and from this equation BS equals to BL equals to B minus 4, we derive that BS is also equals to B minus 4. Here BS is also equals to B minus 4. So in conclusion, we found out that BS equals to B minus 4 and AS equals to A minus 4. Okay? And we know that AB is the diameter of the big circle and the radius of the big circle is 13 units. So the diameter is always twice as long as the radius. So if the radius of the big circle is 13 units, then the diameter of the circle must be equal twice as long as the radius. That is to say, it is 13 times 2, that is 26 units. The diameter of this circle, AB equals to 26 units. And from the drawing you can see that the diameter AB that is equal to 26 is equal to AS plus SB. AS is A minus 4 and SB is B minus 4. So in conclusion, the diameter of the circle that is equal to 26 units, it is A minus 4 plus B minus 4. So 26 equals to A minus 4 plus B minus 4. That is to say 26 equals to A plus B, minus 4 plus minus 4 is minus 8. So according to equation number 1, 26 equals to A plus B minus 8. We added 8 to this equation and found out that A plus B equals to 34. We squared this equation number 1, and found out that AB squared equals to 34 squared, it is 1156. Then we opened the brackets on this side of equation number 1 and found out that A plus B squared equals to A squared plus B squared plus 2 times AB, it is equal to 1156. Then, because of the fact that angle ACB and triangle ABC equals to 90 degrees, that means that triangle ABC is the right triangle. So we can implement the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, that is equal to C. So the square of the hypotenuse is C squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AC squared, that is A squared, plus BC squared, that is B squared. So C squared equals to A squared plus B squared. C squared equals to A squared plus B squared according to the Pythagoras theorem. C squared is 26 square. 26 squared is 626, and it is equal to A squared plus B squared. Okay? But according to equation number 1, we know that A squared plus B squared plus 2AB equals to 1156. But because of the fact that according to equation number 2, A squared plus B squared is 676, we can substitute A squared plus B squared by 676. We did it, and we got that according to equation number 1, here we substitute A squared plus B squared by 676, and we got that 676 plus 2 times AB equals to 1156. Then we subtracted 676 from this equation number 1, and found out that 2 times AB equals to 1156 minus 676 is 480. So according to equation number 1, we found out that 2 times AB equals to 480. We divided this equation number 1 by 2, and we found out that A times B equals to 480 over 2 is 240. Then we divided equation number 1 by 2, and we got that AB over 2 equals to 240 over 2 is 120. Okay, so AB over 2 is 120. And what is the area of the blue shapes? The area of the blue shape is equals to the area of the big triangle ABC minus the area of the small circle. It is very easy to see that the area of the big triangle ABC minus the area of the circle equals to the area of the blue shape. Okay, so the area of the blue shape equals to the area of the big triangle ABC minus the area of the small circle. Okay, so the area of the triangle ABC is equals to A times B over 2. The base is AC, that is A, times the I, that is CB, that is B over 2. Why CB is the I? Because it gets 90 degrees with the base AC. So the area of triangle ABC equals to A times B over 2, but we already found out that A times B over 2 is 120, so we can substitute A times over 2, A times B over 2 by 120, and the area of the small circle is equals to pi r squared when r equals to 4 units. So the area of the blue shape equals to 120 minus pi r squared, and r equals to 4, so r squared is 4 squared, that is 16. So in conclusion, the area of the small circle equals to 16 pi. And therefore the area of the blue shape will be equal to the area of triangle ABC, that is 120, minus the area of the small circle, that is 16 pi. So 120 minus 16 pi is the area of the blue shape, or in terms of numbers, it is equal to 62 minus 73 units. Okay, so the area of the blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. We finished with the first question, then I presented to you the second question, and we solved the second question in 3 different methods. Okay? So here in the drawing, we have this circle. Inside this circle we have triangle ABC that is inscribed by the circle, and we know that the area of triangle ABC equals to 9 units, side AB equals to 5 units, side BC equals to 6 units, and we want to find out the area of the circle that blocks triangle ABC. Okay, so first of all, from point A, we draw perpendicular on BC, so this angle equals to 90 degrees, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D, and the area of any triangle equals to the base of the triangle, that is BC, times the I, that is DA, over 2. Okay, the area of triangle ABC, that is 9 units, equals to the base, that is BC, times the I, that is AD, over 2. BC equals to 6 units, AD is the missing line segment, over 2. So, in conclusion, we found out that 6 over 2, that is 3, that 9 equals to 3 times AD. We divided this equation by 3 and found out that AD equals to 3 units. So here, AD equals to 3 units. Then we focused on triangle ABC. It's actually triangle AB square, triangle ADB. On triangle ADB, according to the Pythagoras theorem, AD square equals to AB square equals to AD square plus BD square. Okay, this triangle ABD. Triangle ABD is a right triangle, so we can implement the Pythagoras theorem of triangle ABD. AB squared equals to AD squared plus BD squared. AB squared equals to AD squared plus BD squared. AB equals to 5, so AB squared is 5 squared, that is 25. And it is equal to AD squared, that is 3 squared, that is 9, plus BD squared, that is missing 9 seconds. So in conclusion, we found out that 25 equals to 9 plus BD squared. We subtracted 9 from this equation and found out that BD squared equals to 25 minus 9 is 16. We took out of this equation and found out that BD equals to the square root of 16, that is 4. So here BD equals to 4 units. And what is the value of DC? From the drawing it is very easy to see that DC equals to BC minus BD. DC equals to BC minus BD. So DC equals to BC, that is 6 units, minus BD, that is 4. So DC equals to 6 minus 4, that is 2 units. So DC here equals to 2 units. Then we implemented the Pythagoras theorem on the right triangle ADC. This right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, here AC squared equals to AD squared plus DC squared. AC squared equals to AD squared plus DC squared. So AC squared equals to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus DC squared. DC is 2, so DC squared is 2 squared, that is 4. So in conclusion, we found out that AC squared equals to 9 plus 4. 9 plus 4 is 13. So we found out that AC squared equals to 13. We took out of this equation and found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Okay? Then from we define the center of this circle, of the big circle, as point O. Then we join points A and O together by a straight line. Then we extended the straight line AO until it touches the circle point E. So chord AE passes through the center of the circle. Any chord that passes through the center of the circle is defined as the diameter. So AE is the diameter of the circle. Then we join points E and B together by a straight line. So here we have angle ABE that rests on AE, that is the diameter, and any peripheral angle that rests on the diameter must be equal to 90 degrees. Therefore, this angle equals to 90 degrees. Okay? And then we focus on chord AB. On chord AB, we have two angles that rest on this chord, angle AEB and angle ACD. Those two angles that rest on the same chord must be equal to each other. So angle AEB equals to angle ACB because they rest on the same chord. Peripheral angles that rest on the same chord must be equal to each other. We defined one angle as theta. Therefore, from this equation, we can derive that angle AEB also equals to theta. So those two angles, they are both equal to theta. So this green right triangle, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. In this right triangle, the same thing is true. This angle equals to 90 degrees. This angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this triangle, 280 degrees. Then we prove that those two green triangles are similar to each other. Why they are similar to each other? First of all, those two angles, they are both equal to theta, therefore they are equal to each other. Those two angles, they are both equal to 90 degrees, therefore they are equal to each other. And those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we prove that all the angles of triangle AB can go into all the angles of triangle ADC. Therefore triangle AB can go into triangle ADC according to angle similarity rule. And from the fact that those two triangles are similar to each other, we conclude that AB over AD equals to AE over AC. Again, AB over AD equals to AE over AC. Again, AB over AD equals to AE over AC. Okay, AB equals to 5, AD equals to 3, A equals to 2R, it is the diameter of the circle, AC equals to square root of 14 units. So in conclusion, found out that 5 over 3 equals to 2R over square root of 14 units. We multiplied this equation number 1 by square root of 13 and found out that 5 over 3 times square root of 13 for 13 equals to 2R. We divided this equation by 2 and found out that R, the radius of the circle that we are looking for, equals to either 5 over 6 times square root of 14 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, so we finish with the first method. In the next step, I'll show you how we solved the question according to the second method. In the second method, we use the thing that we already found out in the first method. Here, from point A, we go perpendicular on BC. We define the touching point of the perpendicular from point A and BC as D. This angle equals 90 degrees, and this angle equals 90 degrees according to our construction. We have already found out that AD equals to 3 units according to the first method. DC equals to 2 units, and BD equals to 4 units. Okay. Then I presented to you rule number 1. According to rule number 1, we have this circle, if chord AB intersects with chord CD at point O, then AO over OB equals to CO over OD. The intersection point is point O, it must be a curve inside the circle. So if AB intersects with CD at point O, then AO over OB equals to CO times OD. Okay? So we actually can implement rule number 1 in our drawing, because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. We get BD times DC equals to AD times DE according to rule number 1. And then we have BD is 4, DC is 2, AD is 3, and D is the missing isomer, so 4 times 2 is 8. So 8 equals to 3 times DE. We divided this equation by 3 and found out that DE equals to 8 over 3 units. Here DE equals to 8 over 3 units. Then I presented to you rule number 2, and we implemented rule number 2 in our drawing. Here we have this circle. If chord AB intersects with chord CD at angle of 90 degrees, they intersect with each other and create between them 90 degrees at the intersection point, then the following equation is true, that 4 times A squared, 4 times R squared, R is the radius of the circle that contains the chords, equals to A squared plus B squared plus C squared plus D squared. Actually, we can implement rule number 2 in our drawing, because in our drawing we have chord AE intersects with chord BC at 90 degrees. All the angles around point D are 90 degrees. Therefore, at the intersection point, the two chords intersect, create between them 90 degrees. Therefore, we can implement rule number 2 in our drawing. Okay, again, chord AE intersects with chord BC at the angle of 90 degrees. Therefore, we can implement rule number 2. According to rule number 2, we get that 4 times R squared, it is the radius of the circle, equals to BD squared plus DC squared plus AD squared plus DE squared. Here 4 times A squared equals to BD squared plus DC squared plus AD squared plus DE squared. BD equals to 4, BD squared equals to 4 squared, that is 16. DC equals to 2, so DC squared equals to 2 squared, that is 4. plus 8d equals to 3, and 8d squared equals to 3 squared, it is 9. D equals to 8 over 3, so 8 over 3, d squared is 8 over 3 squared, that is 64 over 9. So here we have 16 plus 4 is 20, 20 plus 9 is 29, so we have 29 plus 64 over 9. We multiply 29 by 9 and then we divide it by 9 in order to overcome the fact of this expression. So 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 329 over 9. So in conclusion, we found out that 300 r squared equals to 325 over 63. 325 is 25 times 13. Therefore we substituted 325 for 25 over 13. So r squared equals to 25 times 13 over 36. We took a root out of this equation and found out that r equals to square root of 25 is 5 and square root of 36 is 6. So in conclusion, r equals to 5 over 6 times square root of 13 units. So in terms of numbers, it is a little bit greater than 3 units. So the radius of this circle, it is a little bit greater than 3 units. So in terms of numbers, it is equals to 5 over 6 times square root of 13 units. We finished with the second method. Then I presented to you how to find out the radius of the circle according to the third method. We define angle ABC as theta, and then we have a special formula to find out the area of any triangle. The area of this triangle ABC, that could be any triangle. Side AB equals to A units in its length, side AC equals to B units in its length, and the angle between side AB and side AC is theta. Then the area of this triangle ABC will be equal to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. So we implemented this formula in order to find out the area of our triangle. Here, triangle ABC, according to this formula that I showed to you, the area of this triangle ABC will be equal to 5 times 6 times sinus theta over 2. Okay, the area of our triangle ABC that is equal to 9 units will be equal to 5 times 6 times sinus theta over 2. Because of the fact that we know that the area is 9 units, in this way we can find out the value of sinus theta. That is the only missing variable. Okay, so 9 equals to 5 times 6 is 13, 13 over 2 is 15. So we found out that 9 equals to 15 times sinus theta. We divided this equation by 3 and found out that 3 equals to 15 over 3 is 5. So 3 equals to 5 sinus theta. We divided this equation by 5 and we found out that sinus theta equals to 3 over 5. And we have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. So here, if sinus theta equals to 3/5, then sinus square theta will be equal to 3/5 square. That is 3 squared, that is 9 over 5 squared, that is 25. So in conclusion, we found out that cosine theta equals to the square root of 1 minus 9 over 25. Here we multiplied 1 by 25 and then we divided by 25 in order to overcome a factor with this expression, and found out that cosine theta equals to 25 minus 9 over 25. 25 minus 9, the square root of course, 25 minus 9 is 16 over 25. So cosine theta equals to the square root of 16 over 25. The square root of 16 is 4 and the square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. Okay, then we implemented the law of cosines in our triangle ABC. What is the law of cosines? This is triangle ABC that could be any triangle. Side AB equals to A units, side AC equals to B units, and side BC equals to C units. The angle between side AB and side AC is theta. Then according to the law of cosines, cosine theta will be equal to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay, So we implemented the law of cosines in our triangle. In our triangle, we have here cosine theta equals to 5 square plus 6 square minus AC square over 2 times 5 times 6. Cosine theta equals to 5 square, that is 25, plus 6 square, that is 36, minus AC square over 2 times 5 times 6. So 25 plus 36 is 61, minus AC square over 5 times 6 is 30, and 30 times 2 is 60. So cosine theta equals to 4/5, so 4/5 equals to 61 minus AC square over 60. We multiplied this equation by 5 and we found out that 4 over 5 times 5 is 4. And here we have 5 over 60. 5 over 60 is 1 over 12. So in the denominator we left only with 12. So here we have 61 minus AC square over 12. We multiplied this equation by 12 and found out that 12 times 4 is 48. 48 equals to 61 minus AC square. Then we added AC square to this equation and subtracted 48, and we found out that AC square equals to 61 minus 48 is 13. So AC square equals to 13. We took out of this equation and found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Now I presented to you a new formula in order to find out the radius of this circle that blocks triangle ABC. The radius of any circle that blocks triangle, it is equal to capital R, equals to the multiplication of all the sides of the triangle that is blocked by the circle. In this case is AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. That is, in this case, this is triangle ABC. So it is over 4 times the area of triangle ABC. AB equals to 5 units, AC equals to the square root of 14 units, BC equals to 6 units. So it is 5 times square root of 14 units times 6 over 4 times the area of triangle ABC, that is equal to 9 square units according to what is given us the question. 4 times 9 is 36. So here we have 5 times square root of 13 times 6. We divided both the numerator and the denominator of this expression by 6. So here 6 will get cancelled and 36 over 6 is 6. So in conclusion, we found out that the radius of the circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is equal to 3.00. That is a little bit greater than 3 units. Okay? Thank you very much.